T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have start. Come on, baby.
On September 5th, 1980, the curtain closed on the final act of a technological wonder of its time. A computer, which was the progenitor of generations of advanced IBM computer technology, an early granddaddy of today's electronic brains. It was born out of a scientific push back in the 1950s called Project Stretch, a push to stretch the state-of-the-art in computer hardware. The result was a giant step forward in computer technology. Its official name was the IBM 7030, but the electronic marvel was affectionately called Stretch, a nickname which summed up new horizons of computer design and transistor logic of the 1950s. In 1955, IBM and the Atomic Energy Commission joined forces and began Project Stretch. 6 years later, in 1961, the first computer was delivered to the Los Alamos Scientific Laboratory.
The machine was a very interesting machine in that its technology was developed for Stretch, but really brought about the 709TX, which was the machine that the IBM delivered to the Air Force for part of the Bermuda's defense line. And ultimately that machine turned out to be the 7090. So it preceded that machine in terms of technology. In fact, its technology was embedded in the 7090.
The Stretch was really an important aspect of the development of computing technology, and it used some techniques that have since been rediscovered in the newer technologies, newer computers, such as the error correction codes and array processing, parallel arithmetic processing. These items were abandoned for a while, and now they've come back into the newer computers. But the 7030 was probably the forerunner, maybe the prototype of the entire IBM 360 series, which I think has probably sold more computers than any other series of computers that have been built to this time.
The Stretch reminded me of the early machines where you walked inside of them, except that now they were boxes and you walked between the boxes which contained the machine. It was impressive in that you could see the standing at one end and looking down toward the end of the room, you could see the effects of the shrinking, the parallax that happened. It looked like it went off forever.
Stretch was a huge step in computer development, and its physical size reflected the enormity of that effort. The machine and accessories consisted of 60 units, which required 2,500 square feet of floor space. It used transistors and the newly developed tunnel diodes instead of tubes. Stretch also had a huge memory for its time, several times larger than any of its predecessors. The IBM 704 was the computer in common use when Stretch came along. Stretch had an IBM 7302 core storage, a high-speed, solid-state modular system. Its internal memory was 6 times larger than the IBM 704, with more than 250,000 full 64-bit word locations. The core storage was supplemented by a large auxiliary storage capacity in the IBM 7303 disk. Each disk unit could hold just over 4 million full words. It was possible to address up to 32 disk units. The speed of Stretch was unmatched. It was 25 times faster than the IBM 704. Stretch could handle about 1/2 instructions per second. A complete write or read operation in a full course storage cycle took only 2.18 microseconds. The vast difference in speed between the Stretch and the 704 was due in part to Stretch's transistorized circuitry. The 704 got its life from vacuum tubes. A pioneering new feature in computer science was another reason for its unrivaled speed. It was called Look Ahead, and Stretch had 4 levels of it. This capacity allowed the machine to work on one computation while at the same time retrieving information from its memory for the next 4 instructions. Stretch was endowed with many new computer features never before used and a number of new component systems. The 7302 memory unit and the 7303 disk storage were revolutionary, as well as the 7619 exchange and the 7101 central processing unit. The 7619 exchange channeled information between external units and the core storage. It allowed data processing and input-output operations to go on simultaneously. Some of the devices attached to the exchange were card readers, card punches, printers, magnetic tape units, consoles, and console printers. Of course, the most powerful computer of its time did not come cheap. One Stretch cost $10 million in the early 1960s. It was the first computer designed to be used in research for nuclear power and weapons. Its modeling or simulation feature opened new doors of scientific discovery in the race for atomic development. Stretch's advanced technology led to new achievements in the field of meteorology. Weather specialists, for the first time, were able to accurately chart the flow of storm systems over the Earth. It was also used by the National Security Agency in cryptography operations. In 1971, after 10 years of number crunching for the Los Alamos Scientific Laboratory, Stretch was overtaken by scientific progress. The once most powerful computer had paved the way for new technology. Now it had to step aside for computers like the IBM 360, which was built on the advanced technology developed and tested in the Stretch program. The new computers were much faster and far more reliable, but Stretch could still fill a need in the university setting. Brigham Young University acquired a Stretch in 1972 from the MITRE Corporation. The university also bought one from Los Alamos for replacement parts. Stretch had a variety of uses at BYU. Dr. Earl Woolley used it to compute simple tasks like student grades. It also played an important part in his complex research.
The project I was interested in had to do with the interactions of ions in solution. And the reason that we needed the computer was that we had the ions in simulated places in space and would calculate the exact interaction parameters. And of course, the computer was able to do that because it was such an involved project. The particular program that I ran that was kind of the culmination of the project was a program that ran for 500 computational hours on the computer. It actually took 3 months because they couldn't just run my program all the time, and so they would put my program on when there was nothing else running. To run the program, if I'd had to pay for it, would have cost something of the order of $80,000, but in actuality it cost me about 23 cents for the paper that it was printed on. So it was an impossible project without the 7030. What that real program did is calculated about 250 billion interactions, and although that's not the exact program that I really wanted to do, it would have been impossible to do that one. It was still as close as could physically be done. And the example of the output is just kind of like this, sort of a normal or Gaussian distribution of the ions with their different energies. And this is actually what the output looks like. And as you can see, there's really not much to it, but it represents a great deal of calculations and a lot of cooperation with the computer people in order to even get the thing to run. We had a grading program for the chemistry department that kept track of all the scores of all the students in all the classes, so that just a few minutes' notice we could walk right down in the building and find out where any particular student stood in a class and what he was lacking and how they were doing on exams compared to laboratory and things of that sort.
Other scientific projects at BYU kept Stretch busy. For example, the isolation of carcinogens in the environment, calculating the molecular structure of helium atoms, structural analysis of X-rays for determining trace elements of new particulate matter in the atmosphere, and research on desert animal migration. But in the rapid development of electronic technology, it was inevitable that there would be a time when Stretch must be retired from the university. It was a sober moment for the programmers and specialists at Brigham Young University in the fall of 1980 who witnessed the shutoff of Stretch. BYU's was the very last IBM 7030 in use. Since then, the university has relied on a digital VAX for its computer needs. The digital VAX takes up about 8% of the floor space of Stretch and is much faster than its forebearer. Stretch was retired from BYU to the Digital Computer Museum of Digital Equipment Corporation in Marlborough, Massachusetts. And though Stretch may no longer be churning out the numbers in scientific research, its saga lives on. The impact of the technological push of the 1950s continues to manifest itself in faster, more powerful computers, such as the Cray, which was developed by Cray Corporation and used at Los Alamos. Today, the Cray 1 computer is a 1980 counterpart of Stretch. Like Stretch, it is years ahead of its time. The Cray 1 is at least 160 times faster. Its internal memory capacity is nearly 8 times larger than Stretch, but is many times smaller in physical size. And so science continues to reach for the stars, not only in space exploration, but in every aspect of life here on Earth. Our quality of life today is critically dependent upon computer technology. And that technology has been literally stretched to meet our needs ever since the birth of the IBM 7030. Stretch, a granddaddy of modern computer wizardry.